Welcome back to the video. Today we're going to make a Turing machine for this language, a to the n, and then b to the n plus 1, such that n is greater or equal to 0. So when I started doing Turing machines, I learned my own little method. I like giving numbers to n, so let's say n equals 2. So we're going to have a to the n, so we're going to have 2 a's, and then b to the n plus 1. n plus 1 is 2 plus 1, that just gives you 3. So we're going to have 3 b's. And then my little method I like doing, I like crossing off A's to B's. So if we have 1A, we could cross off 1B, 1A, 1B. We have 1B left over. So that happened to be the case this time. Let's see if it's the case for another number of n. What if we say n equals 4? So we're gonna have 4 A's because a to the n, a to the 4, and then b to the 4 plus 1, which is just 5. So we're gonna have 5 B's. Then for every a we cross off a b, and it looks like that condition holds again. So let's just try n equals 5 one more time. And if there's always going to be one b left over, we found an algorithm and we found a way how we could check if a to the n and b to the n plus 1. So let's say we have 5 a's, and then b to the n plus 1 is going to be 5 plus 1, so we're going to have 6 b's. B, b, b. So we cross off an a, cross off a b, a, b, a, b, a to that b, a to that b, and then we have one b left over, so we kind of found our algorithm. And then what I like to do, personally, I like to write like a little section called algorithm or algo description. That way I don't forget what I'm gonna be doing. I don't think I spelled that right. Description. I don't care. It's about the algorithm, not about spelling. So you could say for every a, cross out a b. And that's gonna be pretty much it. And I like to highlight it so I remember. I don't know, just something I like to do. And then I actually write like the actual algorithm. So I say algo, short for algorithm. So in a Turing machine, you could read, write, or move to a direction. So we're gonna read an A, and then we're gonna write an X. Okay, so that's the first step. And then we're gonna let me see if I could actually put like a little example of a string. Let's say n equals 2. So that means we'll have two A's. A is another tip. Actually draw the string when you're making an algorithm. And then we'll have 3 B's. The only reason we have 3 B's is because 2 plus 1. So imagine like the little head of the Turing machine is right here. So we're gonna read an A and then write an X. So we have an X now. And then we want to get past all the A's. So we could say bypass all A's. This was really tricky to me. So we're gonna bypass all the A's until we get a B. That makes sense. But we got to think about it on the next iteration. What else are we gonna bypass? So we're gonna bypass all A's, voice crack, and then all Y's. And then let's do a bigger string. Let's say n equals 4. So we have 4 A's, A, and then 4 plus 1 to get 5. That's how I'm getting 5 for B. B, 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 and B. So say our head's right here, right? So we're telling our Turing machine to read an A and write an X. That makes good enough sense. So we have read an X right here, but then we want to bypass all the A's. So we want to move this little head until we get a B. So we're gonna bypass this A, this A, this A. That makes sense. But we also want to bypass all Y's because once it gets to the B part, we haven't got there yet. We're gonna replace a B with a Y. So our head's right here, right? We're gonna move, keep moving, keep moving. We want to go until we get a B, but in this case, the B was crossed out with a Y. So we want to bypass the Y as well until we get a B, which would be the next one. It might be easier if I write it up here. X and Y. So now we're sitting on an X. We want to bypass all the A's. We're going to get a Y on our way there. We want to pass that Y as well until we get to this B. So this is just me future proofing it. So we're thinking ahead. So we're going to bypass all the A's and then all the Y's. And once we get to a B, see it right here, we're going to read that B. You could say read, I don't want to say A because that's one of the letters we're using. So you could say read a B and then write a Y. See, now that makes sense why we have the Y there. And now we could kind of loop. So we could say go all the way back. until we hit an X. And then you'll see right now until X. Yeah, I kind of like to draw the little loop. Say we're right here, we would change this B to a Y. Now we're right here. So we're going to pass the Y's and the A's until we hit an X, because when there's an X, to the right of it has to be an A, or if not, we're done. So that's what we're saying. Go all the way back into an X. And then that's pretty much it. We could have a condition once we're done reading all the A's and writing an X. If all we have is Y's, we're pretty much done, because so we have X, 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 Y, Y. Say our head is right here. Normally we would read an A and then write an X and then move to the right, but nothing to the right is going to be an A, so that means we're done matching 1 to 1. So the next thing would be a Y. So from here we could write read a, it's supposed to be a Y, read a Y, and then go right until read 1B. It will make it a little easier when I draw the machine as you go through it. See, we're right here, right? There's no more A's to read, so our algorithm's done. We read all of the, we matched A's to B's 1 to 1. So there's no more A's to the right. So we're hovering above an X. If there's only Y's to the right, like I said, all goes done. Now we're going to read all the Y's, because those are all they were B's. And if we have one B left over, which means our algorithm, it worked, because we said for every A, cross out a B. And then we have one extra B left. So that means it worked, and that means the string is accepted. So let's actually design a Turing machine. Hopefully it makes a little sense. I'll try to run it through once like I start drawing the actual machine. For me, I like drawing my circles really nice. I don't know. I feel like I do better when I do that. So for the machine, we're literally gonna follow what we wrote. So we start at Q0, which is the beginning state, and we're gonna read an A, write an X, and then move to the right. The way you could do that, you do A. Let me see if I can write a little better. A, arrow, X, right. This means read. This means write. This is the direction to move. So you'll kind of understand when I write this, like the way I write it, that's what it means. So we want to read an A. I'm just looking at here. Read an A, write an X. So read an A, write an X, and then move to the right. So let me write our actual string. We'll say n equals 2. That means it's going to be 2 A's. I'm just looking up here. 2 A's, and then n plus 1 for the B's. N plus 1 is n is 2 plus 1 is 3, so we have 3 B's. Okay, so this corresponds to this string. It's pretty much, we're making this machine for this string. In this case, n equals 2. So we're going to read an A. We read this A right here. Going to write an X, and then we're going to move our little head over to the right. I'm literally just following our algorithm. And then here, we're going to bypass all A's and Y's. So we can label this Q1. And the way we could do that is we could self-loop. So we could say, read an A, write an A, and then move to the right. So we're going to bypass all the A's, and pretend this B was a Y. It would bypass all those Y's as well. So we can say, read a Y, write a Y, and then move to the right. So if this was a Y, it would bypass this A and this Y until we get a B. So we haven't wrote that until we get a B yet. So we could say, read a B, write a Y, and then we'll move that to the left. And I'll show you why right now. Then we'll draw a new state. It's Q2. Okay, let me actually run through the algorithm. Let's do a bigger number for n. We could say n equals 3. So we have 3 A's, 4 B's. So right here, we're reading an A, and then replacing it with an X. Head is right here, but we're also moving to the right. Now we're right here. So we're going to bypass all the A's because of this, and all the Y's. In this case, there's no Y's. This is the first iteration of the string. So we're going to bypass all of those, bypass this A, until we hit a B. Now we're right here. We're going to write a Y for that B, and then we're going to move our head over to the left. Okay. and then we want to go all the way back until we hit an X. When it says bypass, let me see, go all the way back until X. So what are we going to see on the way back? On the way back, we're going to see A's, of course, because we're sitting over ones. We could say read an A, write an A, and then move to the left. So this will move it, the tape, or the head, to the left. It will self loop until we give the condition. Right now we haven't gave the condition. But what if the head was right here? We're also going to see Y's on the way back. So read a Y, write a Y, and then move to the left. So now we're telling the machine to move to the left, but we're not telling you when to stop. And then we could tell it when to stop when you see an X. So you could say read an X, write an X, and move to the right. So we're going to keep going all the way back, all the way back, all the way back until we see an X. X is right here. So now our head is right here. But once we see that X, we're just going to read it and then write it back because we don't want to like delete it. And then we're going to move our head over to the right. So now we're sitting above an A. So now this is going to be like our loop. This is the loop right here. This loop. So this is going to do all the matching one to one. So now if we run it again, our head is right here. We could say read an A, write an X. Oop. What happened? I don't want to copy that. So we could say we're sitting on right here. So we're going to read an A, write an X, move to the right. Our head is right here. But remember, we want to bypass all A's and all Y's. This is why we included the Y part until we hit a B. So this A is going to bypass it. Remember, there's a Y over this B. It's going to bypass it until we hit a B. So now we're right here. Once we hit a B, we're going to write a Y and then move our head to the left. So now we're right here. Now we're at this state right here. This state wants us to go all the way back. So we're going to bypass all the Y's. In this case, this Y, we're going to move it to the left. To the left. If we see an A, we're going to bypass that until we hit an X. There's an X right here. And then once we hit an X, we're going to move our head to the right until we're sitting above an A again. So now we come back to this state. So we're going to read an A, write an X, and then move to the right. Okay, so now we're here. We're going to bypass all the Y's. In this case, there's no A's. So there's a Y right here. There's a Y right there. So now we're right here. So now we're at this state right here. We're going to read a B, write a Y, and then move to the left. So we write the Y, move to the left. Now we're at this state. We're going to loop through all these states right here. Bypass all the X's. I'm sorry, all the Y's and all the A's. In this case, there's no A's because they're all replaced with X's. So we're going to keep going until we hit an X. Bypass this one, bypass this one. Okay, so now we're done matching one to one. This is where this part comes in. Let's see if I can highlight. Oops, not a highlighter. That's where this comes in. So we pretty much match one to one. Now we just have to do like the end condition. So we're sitting where we are right now. Read an X, write an X, move to the right. We're sitting right here. So we want to do, we kind of like describe it in the algorithm. Oop, that's not a highlighter. So now we gotta like write this step. So we're gonna read a Y and then go right into a read one B. And the way we could do that, we could say read a Y, write a Y, and then go to the right. So now we're right here. And then we can make a different step, a different state, call it Q3, and then we can loop through all the Y's. Read a Y, write a Y, and then move to the right. So this will get us through past this Y and then past this Y. Now we're right there. We really haven't told the machine to do anything with the B's yet. Then we can have another like transition or whatever it's called. Read a B, write a B. See if I can make that a little neater. But I'm not editing this, so I'm sorry. And then move to the right. So now we're told that if we read a B, write a B, move to the right. So now we're right here. Keep in mind, the tape is only this long. It's only this long. After there's no more characters, all it is empty strings or blanks. So if we read a blank, that means our algorithm like finished successfully. So the way we could do that is we could have another state. Let's see if I can make it a little better. like that, and then we'll call that Q4. And from this state, so in my class, we call this just a blank. This equals blank. That means there's nothing there because there's no more characters. So we'll say read a blank, write a blank, and then move to the right. And then from there, we can hit the accept state. And then I'll kind of run over the machine again using like an actual string or whatever. So I always check, for me personally, I always check if what is n equals 0. Is the empty string allowed? So there would be 0 a's, but b to the n plus 1. B to the n plus 1, n in this case is 0 plus 1. So when n equals 0, that means there would only be one b. So we could do from the beginning. See if I can make this look a little better. This is gonna go like check if there's one b. Read a b, zoom it in. Read a b, write a b, and then move to the right. Say n equals 1, n equals 0. I mean, there's gonna be only one b. So this checks if there's one b, this right here. If there is, and there's nothing after it, just go to the accept state. And that looks like that should be our machine right here, our Turing machine. And then let's do a number, like a random number. Let's say n equals 4. This would be a pretty big size string. So n equals 4a to the n, so there's going to be 4 a's. 1, 2, 3, 4, n plus 1. So n plus 1 is 5, so it's going to be 5 b's. Okay. So now we start off right here at Q0. Q0 tells us to read an A, write an X, and then move to the right. So we're going to read an A, write an X, and then our head is right here above that A. And that's telling us to bypass all the A's and all the Y's until we hit a B. I'm at this state, so we're going to move this over A, oh, we're at a B. So now we're right here. This is telling us to read a B, write a Y, move to the left. So we're going to write a Y, move to the left, or above this A. So now here we're at this state. So this is telling us to go all the way back until we hit an X. So this part is just telling us to go all the way back. So if we see an A, we're going to move left. Oh, there's an A right here, move left. A right there, move left. And now we're right here. It says if you see an X, write an X, move to the right. Oh, I forgot to write that. Now that's state 2 where we're at. If you see an X, write an X, move to the right. So now we're right here. So now we're back to Q0 and the loop starts again. So if you see an A, write an X, move to the right. Right there. Back to this state at Q1. Bypass all the A's and Y's. So we're going to see an A right here, move to the right. A Y right there, move to the right. Now we're right here. Now we're above a B. It's telling us if you see a B, write a Y, move to the left. Here. And now, let me get rid of these. Now we're right here. Now we're going to go to the left and pass all A's and all Y's. A right here, A right here. And then you're going to keep going to the left until we hit an X. Now we're at this state. If you see an X, write an X, move to the right. That just moves us to the right because we're just reading and writing the same letter. Back to Q0. Read an A, write an X, move to the right. So write an X, then we're right here. Bypass all the A's and Y's. There's an A right here, move to the right. Y right there, move to the right, move to the right, until we hit a B. So we're above a B. This state, we're going to write a Y. And then we're going to bypass all A's and all Y's. We're at Q2. There's a Y right here, move to the left. Y, move to the left. There's an A, move to the left. Now we're sitting above this X, which is right here. Read an X, write an X, move to the right. So we're sitting right here. We're back at Q0, right here. So it's telling us to read an A, write an X, move to the right. So now we're done with all our A's. Now we got to go bypass all the Y's and the A's. So we're sitting right here. We're at this state. We're going to bypass all the Y's until we hit a B. Hit a B right here. We're at this state. So we're going to read a B, write a Y, move to the left. Write a Y. We're going to move to the left, which is right here. Now we're at Q2. We want to go all the way back to the beginning. We're going to bypass all A's and all Y's. So Y right here, left, left. These are just arrows, they're just sloppy. And then we're going to stop until we hit an X. Once we hit an X, we're going to move to the right. So we're at this state again. So we just did that one. Okay, so this is where we're done checking one-to-one. So you could either read an A, which you already did, or you could read a Y. There's no more A's to read, and we're just sitting above a Y. So you're going to read a Y, write a Y, move to the right. Read a Y, write a Y, move to the right. That just moves us over one state. We're right here. Now we're at Q3. Q3, we're going to bypass all the Y's because we're saying read a Y, write a Y, move to the right, but we're self-looping. Bypass this Y and bypass that Y. And moving to the right. So now we're sitting above the B. If you see a B, write a B, move to the right. So we're not really doing anything, we're just moving over. So now we're right here. We're at Q4. Q4 says if there's nothing there, no more characters, and it's just blank, there's blank right here, we're done. So we pretty much go to the accept state. So this is the Turing machine for the language. A to the n and then B to the n plus 1. Hopefully this helped in any way. I know when I first started doing these were kind of like I don't know, they were kind of hard for me. So hopefully this helped.